In the last video, I said that I would prove this to be true. Unfortunately, it's not real easy. I'll go ahead and do it. Let's look at this from the beginning, and let's just say that we plug in the 2r over na0 back in here, and what that will do is cancel out one of these a sub zeros, cancel out the n, and let's see what happens to the 4. The 4 turns into a 2, if you can kind of follow all that stuff. And then if we just say 1 over a sub 0, then here's what the result is. me squared over 4 pi epsilon 0 h bar squared. But it doesn't prove how we should know this in the first place. If we knew this in the first place, then we could figure out what was going on. What I'm going to prove is that, see, this is just the inverse of a sub 0. If you look down here, that's what we've got here. So what I'm going to do is prove all this, and you can stop the video now and move on if you hate this conversion thing, but I need to do it to keep my head straight. Okay, if we had the Schrodinger equation where we substitute u equals r times function r of r, then it transforms into this. And if we look at that, this isn't really that important. The effective potential is this stuff. That's not that important. What I want to do is move down here to the point where we refactor this a little bit. Here's the h bar squared over 2m, second derivative, and then we set everything equal to, and all this stuff jumps over to the right hand side. Here's e minus h bar squared l times l plus 1 over 2mr squared. That's just this thing. And then the e squared there has a sign change. Well, the sign changed because you went over to the other side of the equation. Any algebra student knows that. So let's go on to this next thing, and I'm going to multiply both sides by 2m over h bar squared. And that'll give us this form. Cleans it up a little bit. And then if we look at r approaches infinity, now that you might not have expected this one, but as r approaches infinity, then these terms go away, because those just essentially zero out. And then we're left with this minus 2me h bar squared. So we can come up with the similar exponential form for u of r as we did for r of r, and instead of minus rho over 2a, instead of minus rho over 2, we come up with this, minus 2me h bar squared. Now what I'm going to do is define k to be this constant. That's square root of 2me, and brought the h bar squared out of the square root, so it's just h bar. What I'm going to do is make a substitution that k equals this value. And so rho is going to equal 2 times k times r. So this is what we've got to think about. We had rho equals 2r over na sub 0. Now we've got rho equals 2 times k, where it's this constant here, not too friendly, and then we've got the r variable there. With these values, if we solve to the Laguerre polynomial, this is what we would get. Most of it looks the same. Here's the one we solved before ourselves. This is the same. This is the same. And this is not the same. Instead, we come up with this me squared over 4 pi e sub 0 h bar squared times that constant, where the constant is this square root of minus 2me over h bar. I'll let your mind settle a little bit. I'll let mine settle a little bit. And then what we'll do is say, well, if this was n here and it's this glob here, then I can set n equal to this whole thing. And that's what I've done right here. Now that we've set n equal to this glob here, let's go ahead and write it. N equals me squared over 4 pi epsilon 0 h bar squared k. Now what is k exactly? Well, k is square root of minus 2me. So what I've done is I'm going to do several things at once. First of all, I'm going to bring the minus 2me over here, which shows that I'm squaring it. And that means that I've had an h bar up here, and this becomes an h bar to the fourth, and that's an h bar squared up here once we square this side. That might be a little hard to follow, but that's going to be as close as I get on this video. So I've still got the 1 over n squared, because that n came over here. So let's stare at that and see if you can buy all that stuff. Notice I've got 4 pi squared, epsilon 0 squared, h bar squared, which was to the fourth, but we had another h bar squared up here, so that canceled that. I mean, it didn't cancel it out, but it brought this down to h bar squared rather than h bar to the fourth. And the m squared e to the fourth, that's not too surprising. Now what I'm going to do is solve for e, so I'm going to multiply both sides times -1, or divide both sides by minus 2m. And what that does is, by dividing by m, this goes from m squared to an m, and this has a 2 down here in the denominator, and that's a 4 pi squared. Those are still the same, 1 over n squared. So what else can I come up with? Well, from the Bohr atom derivation, E sub n this is the key to the whole thing. E sub n equals minus h bar squared over 2m a sub 0 squared, 1 over n squared. So now I've introduced a sub 0, and I can compare these two. These are both energies, so I can equate those energies. So what I'm going to do is exactly that. Both of them have a 1 over n squared, so I'm going to toss that out of the window. And that leaves me with minus h bar squared over 2m a sub 0 squared. And then bringing this thing over here, there's the minus m e to the fourth, 2 times 4 pi squared, e sub 0 squared, h bar squared. I'm going to bring a sub 0 over on this side, a sub 0 squared, and then I'm going to invert all of this stuff. All the numerators become denominators, and denominators become numerators. So that leaves me with the 2 4 pi squared, e sub 0 squared, h bar. All that went up into the numerator. This h bar squared over 2m remains there. And then I have an me to the fourth, which got brought down here into the denominator. Okay, great. The 2's cancel. 2's cancel. And what else happens? Well, if I take the square root of all that stuff, then this was h bar to the fourth over here. See, those two combined together. And then take the square root of that, brings me back to h bar squared, 4 pi squared e sub 0 squared. That just comes out that way. And then I've got me squared. So if you look at these, they're the same. So I've accomplished what I set out to. Watch this video several times until you get that figured out, or don't watch it at all. Maybe that's the best choice.